Hello, we're Team UMass Law. I'm Zhao. We also have Jordan Allspaw here. Brian, Alexander, Jenna, and Daniel also contributed to the project. Our advisor is Professor Holly Yanco. In our project, we are trying to enable a robot to communicate its intentions and actions using a projector, showing us which object it's going to grasp or where it's going to navigate. To achieve our goal, we first implemented projection mapping of objects and navigation cues. We then fused data from a time flight slider and a large angle sensor to detect where people are facing. So the robot can adjust the projection. And then people can always see the projection to better understand the robot. To mount the time of flight lidar and the large angle sensor to our robot, we designed a stable yet compact structure with 2 mounting points on the robot's upper back area, as you can see from the bottom left. With the structure, we mount 2 turrets, one to tilt the projector, located over the robot's head, one to rotate the time of flight lidar and the large angle sensor to find humans. To connect the turret with the 2 sensors, we also designed 2 mounts to attach the sensors to the turret's top. Here is an example of the robot projecting what it is doing onto the table surface in front of it, highlighting the object it will be grasping in green, and marking other detected objects in white. Note that the structure is still from our first generation, which is different from the previous slide. The robot scans the scene for collision avoidance and picks up the green object it's highlighted. But if the nearby person would have a block view of the workspace in front of the robot, projecting onto the table will not be able to help them understand what the robot is doing. Instead, the robot should project an image onto a nearby flat surface that the person will see. Here, the robot is doing exactly this.
Unfortunately, due to the quarantine, we lost physical access to the robot. However, we continued doing what we could in simulation. We investigated how to detect human orientation, as shown in the top left. We finished tracking IR light source over a person's head to get additional orientation information, shown in the bottom left. We also implemented navigation projection, where the robot projects arrows onto the ground, indicating where it intends to drive. Finally, our robot can find nearby planes, such as walls, to project onto. Those were our project highlights. Here on the left is a photo that shows a spotlight of our teamwork. Overall, we had a lot of fun with this project, and we encourage you to look at our final report where we go into more detail with more photos and block diagrams. Thank you very much for watching.